Hi there, this is Megan Swart and I am declaring that this is my own work. My student number is 324-66434. Today my investigation is part 2, and part of providing a solution to this investigation includes presenting a lot of proof and reasoning. First, I interpreted the question. The focus or problem in the investigation is finding what the relationship is between rectangular shapes and the number of squares within them. I found that there was a relationship through exploring linear expressions, in particular the formula y equals mx plus c. Gathering the data. The question asked to find a relationship between the rectangle and the number of squares inside it. Hence, to gather data, I generated a few examples. Originally, the rectangle here is made up of 6 squares. Therefore, I noted that the symbol x was the number of visible squares the rectangle was made up of. Exploring this systematically. To be able to identify patterns, I constructed a two-way table from the beginning. So far, I know that x equals 6. I started to ask questions about the data. For example, if x is the original amount of squares, then what could y possibly stand for? I looked back at the question. So far, I know the original amount of squares in a rectangle. However, the question is asking for a relationship, and this is where my investigation truly began. I started to explore the squares within the rectangle to identify what the relationship may be. I found that there could also be larger squares within the rectangular shape, which meant that there was originally 6 squares, yet actually 8 squares. If x is the original amount of squares, then y must be the actual amount of squares. This is the relationship I found. I added this to the two-way table. To conclude, if there is originally 6 squares in a rectangle, there is actually 8. I tried another example with the original amount of 8 squares, or x equals 8. I looked for larger squares outlined in red, and I found that y equals 11. I decided generating one more example will help with the accuracy of my data collection. Therefore, x equals 10, or the original amount. How many squares are there actually? There was 14. If we started to examine the two-way table, maybe I could identify a pattern. So far, I can see that x goes up by 2 and y goes up by 3. Using y equals mx plus c, I needed to work m out first, which is the gradient. The change in y is 3 and the change in x is 2. Now that I've figured out m, substituting x and y from the two-way table will help me figure out c. I substituted x and y, as you can see, and it showed that c equals -1. Knowing c equals -1 completed the formula. Because x needs to go up by 2 every time, because a rectangular shape is formed with even amounts of squares, the conjecture therefore is that any even number can be substituted in the place of x in the formula to find y. I substituted both 12 and 14 into the question to find y. In testing so far, I'm aware that there is a chance of a boundary. However, I have explored up to x equals 1000 without a boundary forming. Therefore, I can conclude so far that the formula is not limited or has no boundary up to x being 1000. The formula helped me conclude that the relationship between the original amount of squares in a rectangle and the actual amount can be written as y equals 3/2 x take 1. I adapted this problem for Year 7 students, and the curriculum definitely needs to be considered. At a Year 7 level, students are being introduced to linear relationships and algebraic expressions and are able to use tables to document their data. Giving students a two-way table with x as the original amount of squares and y as the actual amount of squares will aid them in exploring the relationship. They have the opportunity to create an algebraic expression and evaluate it. To cater for all students, different expectations will be set from the start of the lesson. Some students will only just find all the squares in the rectangle, others will be able to use the data and document it, some will find a pattern within the data on the table, and most advanced students will be able to formulate an equation. To start, I would adapt the question. This question is less vague, which will help students direct their attention towards the relationship they are exploring. By handing them an activity with a few rectangles, I would encourage students to start working in pairs to find a possible relationship. All students will be told what is expected of them individually as well as in pairs. They will have 2 class lessons which will be given as a time frame, and they will be left to explore. they may possibly realise that the rectangles have larger squares that can be formed inside them. To help them explore this further, guidance will be given through providing cutouts of rectangular shapes. By folding the shapes on the dotted lines, students should be able to see that there are larger squares as well as the original amount of squares. Those students who are able to recognise this will be encouraged to document their data on a two-way table. This is the two-way table. Having folded the dotted lines, they can record the actual amount of Y, and those who don't need extra support with recording the data will fill out the table to look like this. Those who are excited to explore the relationship expressed in the table can be further encouraged to start identifying patterns in regards to X and Y. Possible answers students could have is that X goes up by 2, Y goes up by 3. Some students may also recognise that the table goes up by 2, 3, then 4. This is where students may get confused and need a bit more guidance. Some will use the information to formulate an equation to express the pattern. As a teacher, I will encourage students to use the equation y equals mx plus c. They need to solve to find m and c, or the gradient and c, to formulate the formula. Only advanced students are expected to complete this activity as it is beyond the introduction to linear equations and algebraic expressions. Thank you so much for listening.